2-3, rate of change and slope. This lesson's all about rate of change. Let's talk about rate of change and what it is. The rate of change is a ratio that compares how much one quantity changes on average to the change in another quantity. The key word here is ratio. You should always think about it as a fraction. The rate of change is the change in y. That's the triangle's change in physics. You'll see it there. Triangle means change. Change in y over change of x. A good way to find the change in y over change of x is just to do y2 minus y1 over x2 minus x1. First example, let's find the rate of change for each data set. We're going to find the rate of change of this thing here. In this case, it's a linear line. It doesn't matter which two you pick. They're not specified. So I'm going to say, let's find the rate of change here to there. Now remember, it's the change in y over the change in x. That's my x values, input, my y values, output. Let's say x1, y1, x2, y2, right there. That's going to be 36 minus 12 feet. Keep the units over 6 minus 2 minutes. 36 minus 2 is 24 feet over 4 minutes. And we can divide that and get 6 feet per minute. Now keep in mind, units matter. Rate of change should tell you something. Same as the next one, we'll just worry about these two right here. Again, it's a straight line. They don't specify. You pick any 2 points you want. X and y. We're going to do change in y over change of x. y2 minus y1 over x2 minus x1. And then x2, y1 and y2. Minus 16, again, don't forget the units, centimeters cubed, over 10 minus 5 seconds. Subtract, you get 16 centimeters cubed over 5 seconds. This goes, it increases, it's a positive value, it's an increase 16 centimeters every 5 seconds. Every 5 seconds, you get 16 more centimeters cubed. That's the basic idea of rate of change. Now, these were all straight lines, so it didn't matter what two values you picked. For our next one, life isn't all straight lines. We're going to have to start doing things where it changes, where things are not constant. The rate of change fluctuates. Here's our first example. The graph shows the number of digital still cameras and film cameras sold by yellow camera stores in recent years. Find the average rate of change in the number of digital cameras from 2004 to 2009. We're going to do digital cameras in 2004 to 2009. So here's our graph. Digital is the blue one. So we're going to start at 2004, which is 20, but in thousands. This is going to be our x's. So we have y1. So we're going to look at 0.4 and 20. And then we're all the way to 2009 right here. X2. My y2, let's say 76. To round it. Let's find the rate of change. y2 minus y1 over x2 minus x1. That's going to be 76 minus 20. And again, this is units. 20 right there. And 2000 minus 2 years. And I get 56 over 5 years. Every 5 years, it goes up another 56,000 units, roughly. Now, B says this is the same thing for the number of film cameras sold. People don't use film anymore. You see it's going down. I'm going to do the same thing, I'm going to do a little faster this time. We're going to have 2004 and 60. And right here, we're going to have 2009. And round again. 36. We're going to get 36 minus 60. It looks terrible. Over 2009 minus 2004. I get negative 24 over 5 units per year. Forgot the units per year. Now look at this one. It's a negative. It's going down 24 every 5 years. Every 5 years, we lose another 24,000 units. That's what C is. What does a sign change represent? Positive signs means you're going up. You're increasing units. A negative sign change means you're going down. You're decreasing in units. That's what the sign represents in each change. If you haven't noticed by now, rate of change is slope. Oh my God. But that's the whole idea. Rate of change and slope are one and the same. They mean the exact same thing. If I ever ask you to find the slope of something, I just want you to find the rate of change of it. All we're going to do is use a formula. Change of y over change of x, which is y2 minus y1 over x2 minus x1. Also known as rise over run. In this case, rise is going up, minus is going down, and we always run to the right. That's rate of change. The big idea here, rate of change and slope are the exact same thing. You find them the exact same way. If I say find the rate of change, you do this. If I say find the slope, you do that. Or you can do rise over run. First problem, hey, let's find the slope of these things, or the rate of change of these things. So we're just using the formula, y2 minus y over x2 minus x1. Now, when you pick one, that is x1, y1. It doesn't matter which one you say is x1, y1, but that has to be an x and a y. Same thing here. Has to be an x and a y. You just plug it in. 12 minus 2 over 8 minus 3, and I get 10 over 5, or just known as 2. There's no units here, so I'm going to write it, but there you go. This one's the same thing. Again, just keep in mind that this is an x and a y. The biggest mistake people make is they put two x, put x1, x2. Don't know why, but whatever. Use the formula. 10 minus negative 5 over negative 7 minus negative 2. Two negatives make a positive. That becomes plus, and that becomes plus. 10 plus 5 is 15. Negative 7 plus 2 is negative 5, so negative 3. That's how you find slope or rate of change through any 2 points. Now, how about if I give you a graph? So here, let's talk about a couple steps first. First step, you want to find 2 nice points. What do I mean by that? Find 2 places where they cross nicely. Like right here. It's a good point, right there. Cross nicely. See, I have no idea where that crosses at. That's not going to help me. Nowhere here, but here. That point crosses nicely. In this case, I have the point negative 1, 2. And right here, I have the point 0 and negative 2. Find 2 points, and then it's your choice. You could either do y2 minus y1 over x2 minus x1. Or since we have a graph, you could do rise over run. Let's do both real quick. If I use the formula, just pick that one be x1, y1. The other be x2, y2. If I use the formula, I'm going to get negative 2 minus 2 over 0 minus negative 1. Negative 2 minus 2 is negative 4. 0 minus negative 1, 2 negatives make a positive, so just 1. I get negative 4. Just using the same slope. Find 2 points first that cross nicely, and then use the formula. Other way of doing it is use rise over run. Remember what I said before? Rise is going up, run's going down. He always goes to the right. If I'm going to do this, I start on the farthest left point. I got to get to that point here. I got to go down 1, 2, 3, 4, and go over 1. Negative 4 over 1, also known as negative 4. Either way works. That's how you find the slope with 2 things. Let's try it again right here. And let's see, find 2 places that cross nicely. I guess right here and right there. Now I'm going to do the rise over 1 because it's a little faster in this case. Now keep in mind, this one is going by 4s because the book 8-2. It's 20. And I'm going up, positive. I went from, let's see, 4, 8, 12. Rise or run. I went up 12 and I ran 20. 12 over 20, if you want to reduce it, divide by 2. 6 over 10 or 3 over 5. And that's how you find slope if I give you a graph. If I give you a graph, find 2 points. Then either do the slope formula or do rise over run. Let's talk about slope-intercept form next. The slope-intercept form is this form right there. Basically, it's when you solve for y. It's good for a couple reasons. First, makes it easy to find the slope. And second, it makes it easy to graph. If you ever want to graph something, the easiest way to graph is put in slope-intercept form. Also, the easiest way to find slope is to put in slope-intercept form, hence the name. And the reason it's called slope-intercept form is because this form tells you 2 things right off the bat. The thing next to your x, the coefficient of the x, is the slope, and the b, the constant, is the y-intercept. Hence, slope-intercept form. Slope and y-intercept. And all you have to do is solve for y. Get y by itself, the coefficient of the x is the slope, the constant is the y-intercept. Determine the rate of change. Remember that just means slope. We're just going to find slope. Solve for y. So we're going to add 16x plus 641. Remember, it's a positive 41, so plus 41. Divide by negative 2. Now, when you divide by negative 2, you got to divide everything by negative 2. No shortcuts. So y equals negative 8x minus 41 over 2. I don't care about that side. All I want is the slope. And my slope here is negative 8. That's the slope. Next one. Same idea. Oh, it has fractions. First, we'll get y by itself. Let's subtract 3 over 2x minus 3 over 2. So negative 5/4 y equals negative 3 over 2x plus 15. The way you get rid of a fraction, you just multiply by the reciprocal. So we multiply everything by the reciprocal of this. Negative 4/5. Negative 4/5 cancels out. You just get y. Over here, you get negative 4/5 times negative 3/2. Negative 4 times 3 is 12. And 5 times 2 is 10. Then plus 15 times negative 4/5, which will just be negative 12. So my slope here is just 12 over 10, or 6 over 5. Again, easiest way to find rate of change is this. If you have an equation, just put it in slope-intercept form. Solve for y. Easiest way to find the slope if you have an equation. If I give you a graph, find 2 points. And once you do that, either rise or run, or do the formula. If I give you an equation, put it in slope-intercept form. Okay, one of the last things we're going to do here. Find the value r so the line that passes through each pair of points has a given slope. So they're telling you, hey, here's 2 points, and that's the slope. Find r. Well, if you have 2 points, you have a slope. Why don't we use the equation for the rate of change, or the slope? That's its rate of change. It's y2 minus y1 over x2 minus x1 equals the slope. Well, we have everything we need. Let's say this is x1, y1, x2, y2, and this is my m. Plug it all in. So this is negative 3. This is r. This is 4 minus 10, and this is 4/3. Let me rewrite it real quick. I mean, it's not going to look much nicer. I get this. Now we got to do some math. 4 minus 10 is negative 6. You could cross multiply here, I used to love cross multiplying when I was a kid, but now I've realized I don't really need to do it as much as I used to think so. Let's multiply both sides by -6. Less work. -3 minus 5 equals -8. -24 divided by 3 is -8. Or reduce and multiply. That's an r, not a 5. Plus 3 plus 3. -r equals -5. R equals 5. And that's the idea. This will be the same thing. We're going to skip it because it's the same thing. The table shows your height at a water slide at various time intervals. Graph the height versus the time on the water slide. This is time, and this is height. At 0, I'm at 120. At 1 second, I'm at 90. At 2 seconds, I'm at 60. 3, I'm at 30. Then I'm at 0. It goes like this. Find the average rate of change. Now, the reason it says average, because it's going to change. If you see it, it's not the same. In general, when they say average, it's not going to be the same the whole time. I guess right here, it's not 30 anymore. It's a -30, then it stops. So I want to find the average rate of change between 1 and 3 seconds. Now, they told me 1 and 3. I'm going to use 1 and 3. So when they give the actual values, you got to use those values. So this is my x, this is my y. They want the rate of change. Let's be y2 minus y1. That's a b. Over x2 minus x1. Let's say this is x1, x2, y1, y. I get 30 minus 90 feet. Notice again, there's units. Got to add them in. Over 3 minus 1 seconds. I get -60 feet over 2 seconds. Or -30 feet per second. I like to think of it as a fraction. You're going down 30 feet every 1 second. Every 1 second you go down about 30 feet. C. Find the average rate of change in the writer's height between 0 to 5 seconds. So now they want me to do the same thing but from 0 to 5. I'm going to use this as my x1, y1. I'm going to use this as my height for x2, y2. My values for x2, y2. Same formula. And then I'm going to plug it in 0 minus 120 feet over, don't forget the units, 5 minus 0 seconds. -120 feet over 5 seconds. You can divide that, you get -24 feet per second. Over the full first 5 seconds, you're going down 24 feet every second on average. Right, the first 3 where it's really steep, you're getting 30 feet per second, but over the whole thing is 24 feet per second. And D, what's another word for rate of change in this situation? Speed. Or rate of change, speed, slope, all the same. And that's the lesson.